All right, this is for 3.4, 3.5. This is the optimization problems, the word problem section. It says find the price, this is number 6, find the price that will maximize profits for the demand and cost functions P equals 40 over the square root of x and C equals 2x plus 50, where P is the price per unit in dollars, X is the number of units, and C is the cost in dollars. When the profit is maximized, what is the average cost per unit? Okay, so the first thing is we can't really do profit being maximized until we know revenue. So I always highlight what they're asking us to do, so that kind of keeps a goal in mind of what we're looking for. We're also going to have to find the average cost function eventually. But we did talk about in class how with a lot of these, you have to be really careful about your domain. So when we get to that in a minute, I'll tell you how I found that. It's not something we would test on when a problem is this hard, but it is good to know. So we need to find the revenue function. Remember, revenue is always the quantity of units produced or made or sold times the price, and P has been given to us. So this is x times 40 over the square root of x, or 40x over square root of x. Another way we could think of that is 40 and then x to the 2 over 2, x to the 1 over 2, because you can turn them both into exponents. I chose 2 over 2 since the bottom has a 2 for its denominator. And then we can use the rule that says you can subtract exponents. So this is actually just 40 to the 2 over 2 minus 1 over 2, which is 1/2. So my revenue function is just 40 on the square root of x, or 40 times x to the 1/2, if you want to write it that way. So then if we want to do our profit function now that we have our revenue function and we also have our cost function, remember you take the revenue function and you subtract the cost function. So profit would be 40 x to the 1/2 minus 2x minus 50. Okay, so then we want to maximize. That means take the first derivative. So this would be 1/2 of 40, which is 20. We would lose a power, so that's going to be x to the negative 1/2 now. And then minus 2 for the derivative of this term, and then this would be nothing. If we want to find our what our max profit critical value of the units is, we'll set this equal to 0 and solve. So I would add 2, divide by 20. So that's 1 over 10. This is the x to the negative 1/2, so I'm actually going to flip it, make it 1 over x to the 1/2. Cross multiply, so we get x to the 1/2 equals 10. And then we would square both sides to get rid of that square root. So this is going to be x equals 100. So remember, that's our critical number. Okay, and if they wanted to know how many units we needed to sell to maximize profits, that would be the answer for that part. But they actually asked us, when the profit is maximized, what is the average cost per unit? So there's a couple things I always do. I always go ahead and find the price. So P was 40 over the square root of x, which is 40 over the square root of 100, which is 40 over 10, or 4 per unit, so $4 per unit. Average cost, so this is going to be our maximum price for profit. Average cost function, remember, is C bar. So we take our C function, which was positive 2x plus 50, divide each term by x. That's 2 plus 50 times x to the negative 1. And if you want the average cost, we would just plug in the 100 for that. So we might want to write it as 50 over 100. That would be easier. So then this is 2 plus 1/2, or $2.50 per unit. Okay. Now, the only thing we didn't talk about in this problem was the critical number we found even okay to use? Because there is an implied domain here, and that's found by looking at what values can you plug in for x to the 1/2, because that's this function we had right here, our profit function. This sort of looks like a quadratic, since we have a power that's 1/2 and this power is 1, so we could rewrite it as negative 2x plus 40x to the 1/2 minus 50. To be able to call something quadratic, the first exponent has to be cut in half to make the second exponent, so that makes it quadratic-like. So if we did x to the 1/2, not x, and used the quadratic formula, that'd be negative b plus or minus square root b squared minus 4ac all over 2a. That gives me x to the 1/2, and I worked it out and got one of them, it was 10 plus or minus the square root of, 8.66 once I took the square root, all over like 2. Anyways, this part doesn't matter as much because I told you this is not the answer to the question. It's just knowing if your critical number makes sense. And then you have to take the square root of both of these once you get the answer. So I actually got that x could go anywhere between 2 and 348. So we did a lot of these in class where we said that this is actually the hardest part, is trying to figure out what the possible numbers are for the critical number range. But most of the time you can just solve it and it works out just fine. So in this case it did. But you'd have to have done quadratic formula to find that. So it's a little bit of a mess. All right. The last one I wanted to do was number 8, which is the point of diminishing return again. So we're looking at the profit function, negative 2s to the 3rd power plus 35s squared minus 100s plus 200, where s is the amount they spent on advertising in thousands of dollars. We want to find the advertising amount that maximizes the profit. So maximize, remember, means take that first derivative. So that would make this negative 6s squared plus 70s minus 100. And then we would need to we could actually do, we could do a second derivative test as well if we wanted to. We will do the second derivative in a minute, but let's see if we can solve this. I believe I can pull out a negative 2 out of all of them. So that'd be negative 2. This would be 3 squared then minus 35s plus 50. Then we tried to do factor by grouping. That's 150. Factors of 150, let's see. So 150 divided by 2 is not going to help us. 150 divided by 3 is 50. 150 divided by 4 is not going to go evenly. 150 divided by 5 is 30. And we're looking for them to, add to 35, so that'll work. So we're going to break this up into 3s squared minus 30s minus 5s plus 50. We'll factor out a 3s out of the first pair, and we'll factor out a 5 out of the second pair. And that gives me 2 possible factors here. So p prime is negative 2 times s minus 10 times 3s minus 5. If we solve that, s equals 10 or s equals 5/3. We want to figure out which one of those is possibly a max or min, because remember we want the maximum. So we can do our little sign chart. 5/3 is smaller, 10 is bigger. We pick critical values on each side, so 0, maybe 6, and 12. Plug them into the first derivative. So if we plug in 0, that's just going to be a negative. If we plug in 6, we'll have to use our calculator. So 6 squared is 36 times a negative 6. And then plus 70 times 6. Then minus 100. So that's 104, so that's positive. And then we need to check 12. So 12 squared times the 6 that's negative plus 70 times 12 minus 100. That one comes out negative as well. So decreasing to increasing is a minimum, increasing to decrease, or decreasing is a maximum. So they need to spend 10 $5,000 on their advertising. The point of diminishing returns, we need to take the second derivative for that. So P double prime would be negative 12s plus 70. And if we solve that, we would add 12s over and then divide by 70 by 12. It's going to come out to a decimal. So S would be 5.83. And then we would remember that this is thousands. So this would be 5 times 1,000, 5.83 times 1,000. So that is 5,833.33. Now that is the advertising. Now we haven't found everything. When you do a point of diminishing returns, you also need the profit for that. So we need to take that and plug it into our original function. So hang on just a second. So we would get, let's go back to the original. It's going to be that number cubed. So we can use the decimal point when we're doing the cubing part. So this is, because you're plugging it back into a formula that had it written in 1,000, which means you can cube it. Oops, that did not let me do what I wanted to do. It needs to be raised to the cubed power, and then times by -2. And then we had plus the 5.833333 squared, and then times 35, because this is back at the original function, and then minus the 100 times the 5.833333, and then plus the 200. So 410.65, which means and I believe this was in thousands as well, but let me double check in the problem. Yeah, the profit would be in thousands as well, yes. So this would be 410,650 and 410,650. I'm going to double check myself. Should just move it 3 zeros. Yeah, but I rounded up. So there we go. So that's my profit. There's the advertising. That's the point of diminishing returns. So if they spend more than this on advertising, they will start losing profit. It will not be a benefit to them. Okay, and that's the end of this video.